Greetings from Calgary. Today I'd like to walk you through building an RFID security system using Microsoft's Gadgeteer. This project is one of my student-friendly projects and shows off why Gadgeteer is good for professionals and students alike. This is the standard RFID door security where you swipe your card or dongle and if approved the door is unlocked. It could be your office, car, hotel, or even home. Now we can sit here and jibber jabber, or we can get into the good stuff. So let's start coding. So I'm using Visual Studio 2013 Universal, and we're going to create a new project. And since I've got all the Gadgeteer stuff installed, and I'll put links for everything down below where to get Gadgeteer and the .NET Micro Framework and the GHI SDK. I'll put links for everything down below, including the source code and everything. So we're going to select that this is a Gadgeteer project, and it's a Gadgeteer application, and we'll come up with a name for it, RFID door, we'll call it that. And we can say OK. And then Visual Studio is going to present us with a list of different main boards. This particular project, we're going to use a GHI Fez Cerberus, which costs about $25. We're going to use the .NET Micro Framework version 4.3, and then we're going to say create, and then Visual Studio is going to go up and build us that project. Now, like I said, I'm using Visual Studio 2013 Universal. You can use any of the free versions of Visual Studio 2012, 2013. The experience that you're going to have is exactly the same. Trust me, when you build devices, you really want to have professional development tools. And when you can get those professional development tools for free, there is absolutely no reason to do this any other way. So, as you can see, now that the project's been created and opened and we're in it now, we're in what's called the designer. And the designer is where we're going to assemble our hardware. This is one of the huge advantages of Gadgeteer. So here's what our main board looks like, and it's a photo of the main board, so it looks exactly like the real one. And so we're going to go into our toolbox, and you can see that, I mean, here's a number of different main boards that are available, and then these are all modules that I have. So there's lots and lots of different modules available for Gadgeteer. And so since we're going to build a RFID device, I guess the first thing we better do is make sure we have an RFID reader. Now, we can either double click on this, or we can drag it off of here and we can set it over here like that. And so there's our module. So we're just going to go in, add some different modules. We're going to need a power module. I'd like to have a tunes module because I want this to make some noise. We'll go up here. I didn't add a relay yet, so let's add the relay. And so the idea of the relay is that this is the sort of the switch that our device turns off and on to operate the solenoid for the electric doors. So this is sort of our connection to the electrical part of our device. We'll go up here. I think we'll toss in an LED so that we can have some color displayed. The LED change color based on different statuses. We'll put in a character display just so we can kind of see what it's doing. And let's throw in a button. So as you can kind of see, here's our main board. Here's all the different modules that we added. So let me just kind of move these about. And like I said, you can arrange these however you wish. But you'll see why I'm kind of doing this here in a minute. And so we'll put this guy over here, put that guy up there, put him down here, and we'll put him down here. So now that we've kind of got all our modules and stuff put together, now comes so how do we wire this up? And so this is, again, another reason why, we like using Visual Studio and the designer and stuff, because it's really helpful. If we look at the modules, we'll see like an X, Y, and that tells you what kind of hardware interface that module has. And if we look for an X or a Y socket down here, we can plug it into there. But that sounds too much like work. So the other thing that we can do is that we can click on it, and it will light up what sockets on the main board will connect with that kind of hardware interface. So we'll put this guy into there, And then we'll do the same thing with the button. So any one that turns green, we can do that. Over here, we'll put this into there. But, you know, we can connect them up like that, or we can just say, go in, connect all modules, and we'll let the designer hook up our hardware for us. So this makes it really easy to do this. I mean, if you compare how fast this is for me to wire up sockets and, you know, use the designer and figure out what I can and can't add and stuff, and compare that to doing like breadboarding or soldering up devices, I mean, this is vastly superior. Excuse me. So now that we've got our hardware all kind of put together, so let's go write some code for it. And I'll kind of describe why I picked some of the devices we had. So let's get rid of some of these comments that the Gadgeteer project put in for us, just because we want to try and keep this really, really clean. So the first thing that we're going to need is we're going to need some way to kind of hold what RFIDs are able to open our lock. And so we'll create a hash table. Sounds like a good plan for that, and we'll call that RFID hash table. And that's going to be, so we'll actually go and create it here. That's fine. Not really too concerned about the capacity for this demo. We're going to create some timers. Now, the reason we want these timers is, for example, when a user isn't allowed or a card doesn't open the door, we'd like to be able to say, well, you know, change the status of the LED to red, maybe put up a message, you know, buzz something, whatever. And so we'll have a deny timer. And we'll make that go for 2 seconds. So this is in milliseconds. And then we want another timer so that when we unlock the door, we only unlock it for a set amount of time, and then the door goes back to being locked. And so we'll assume that that's probably 3 seconds is enough for them to swipe their card and open the door and then go in, and that way when the door closes, it will be locked again. And so that's all that we need up there. And so one of the beautiful things about Gadgeteer is that everything's object-oriented and it's event-driven. And event-driven, that makes sense for devices. I mean, it sits there and it waits for something to happen, you know, for someone to swipe a card, for somebody to press a button, for some form of an input. You know, devices tend to be reactive. I mean, you can have it set up where, you know, I want to get a temperature reading every X seconds or whatever, so I would have a timer in there, and every time that timer ticks down, well, that would be my event that tells me to go get a temperature or whatever. And so Gadgeteer is very intuitive to build products in, because it is event driven with object oriented. So we have a button, and a button has a number of different properties, but it has these events up here. And so when somebody presses the button, there's a button pressed event. And so we are going to go and do something with that event. So when someone presses a button, the code that would be in here is executed. Now, one of the other things that we want to do, you're probably wondering, why are we putting a button in here? We need to have a way to tell our device which cards are and aren't able to open the lock, or more precisely, which cards are able to open the lock. By default, any card that it doesn't know about won't be able to open the lock. So we need some way to be able to teach it that, and so that's why we have this button here, is so that when you press the button, you know, and the GHI modules, the button modules, they have a red LED, and so we're going to configure our button so that when someone presses the button, the LED comes on, it toggles on and off. And so that's under here for mode, that would be a property. And so LED mode, and we'll toggle it when pressed. So that'll just basically turns that light on and off. And we're going to use that as a flag for being in operation mode or in learning mode. So the next thing that we want to do is when the timer fires off, we want to go and do something when that happens. So the unlock timer has a tick event, and so when that fires off, we want to, go and relock the door and such, or turn off the relay so that the solenoid's unpowered and goes back to its default configuration, which is lock the door. Same thing for the deny timer. So when it counts down, we want to do something at that point too. So there's our event handlers for that. Now, so the RFID reader, it also has an event that occurs when it receives when a tag is successfully swiped over it, and it has an ID number. This event is fired off, and so we'll want to go and handle that event. And then, being kind of an old security guy, I like to have my default configuration is locked door, so we're just going to write a routine to do that, and we'll do that right now. So lock door, and there's no parameters that need to be passed to it. And so lock door, what we're going to do is we're going to tell the relay to turn off. We'll say our LED, we're going to set the color, and so our color to indicate to the users that it's ready for something to happen, we'll make that blue. And the character display, we'll just clear that, and then we'll say character display, we'll have it print up a message in that little thing that says that it's ready. And that'll be our locked door routine. So let's scroll up here. And let's take a look now at what we're going to do when someone swipes a card over our reader. So one of the things that we want to do is, if any of the timers are running, then what we want to do is just have it ignore that event. And so we'll just have it do a return. And so that way, if the thing is got the door open or whatever, and somebody else was to come over and swipe a card that maybe was supposed to lock the door or whatever, that would be kind of a little strange. So we'll have it so that it sort of handles one sequence of events at a time and just ignores the other events. So that'll work for there. And then, like I said, we want to see if we're in learning mode or operation mode. And so the way that we're going to do that is we're just going to see if the LED light is on on the button. And if the LED light is on, then we're going to assume that we are in learning mode. And then, so what we're going to do, we're going to check. We're going to make a query to our hash table and see if the ID number, which was scanned, which is passed in here, is contained within our hash table. And so if it's not added, we are going to add that to our hash table. Now I forgot one thing I should do up here, and that is we're just going to clear off the character display, and we'll print the number that we get so that we can see what the number is. And then we will our character display has 2 lines, and so we're going to set the cursor down to the next line. So what we'll see is we'll see the ID number on the top line, and then whatever action was taken on the second line. And so here we've added a number to our list of IDs that will open the lock, and so we will say character display dot print adding. Now let's say we wanted to remove an ID from our list of permittable RFID tags. So if that number was found in the hash table, then we're going to want to remove it. So we'll say RFID.remove, and that gets rid of that from the hash table, so that guy would now no longer be able to open that door, and we'll just say character display print removing. And that handles our learning mode. So if the LED on the button is off, then we're just in normal operation mode. And so we're just going to write a guy called open door, and we're going to see if so what this is going to do, let me just scroll this up so it looks a little more towards the center. So if the hashtag that's given to us is contained within our little hash table, then the door is going to open. Otherwise, the open door routine is basically going to do nothing for us. So let's write that right now. We'll say private void open, case sensitive, and we'll make this a Boolean, and we'll call it open. And we'll say if open, so if true is passed, then we're going to say character display, and we'll do a print, and it'll say enter. And then we're going to play a little tune, play, and we'll make this fairly high pitched, and we'll make it fairly short though. And then we'll change the LED, set color, and we'll change that to green so they know to proceed, green for go. And then the relay, will turn it on. So like I said, I'm going with the assumption that the solenoid by default in an unpowered state has the door locked, and so if we apply a power to it, it slides back and the door becomes unlocked. Now, this is why we wanted those timers. So we have this unlock timer, and we want to start it at this point. So basically, we're going to leave the door open for 3 seconds, and then when this timer kicks out, then we're going to close the door. We're going to relock the door. So, our else condition, we're going to say, so this is in the case where the user doesn't, or the card holder doesn't have access to here. So we're going to say print, and we'll say denied. We'll fire up this tunes module, and it will play something. We'll have a lower frequency for a longer duration, and then that way it becomes sort of doubly noticeable that that something has happened. Now, I should mention that one of the beautiful things again about Gadgeteer modules is that in the drivers they can place code that makes it really easy for us to use. So even though this module is going to play a tune for a half second, or in this case a second, it doesn't stop our code because this is threaded. And so it fires off on its own thread and plays, and we just continue executing on. Really nice way to do it. And then we'll set color, and we'll set this to red. Just to be sure, we'll make sure that the relay is turned off. And then, but we'll start with this deny timer, so that at some point we can go and do something. Like we can change that LED off. So let's go and do that right now. And so the deny, well, we only want this timer to run once, so we're just going to do a stop on that, and then we'll say lock door. And we come down here to the unlock. We basically want to do the same thing. If we really wanted to, we could have had both of these go to the same timer. That's the unlock timer, so we want to stop that. And then we want to lock the door. And that takes care of that. So now the last routine that we have to write is this thing where we're basically going to have two modes of operation for our device. We're going to have the learning mode and the regular mode. And so we'll clear the character display, and then we'll come down here and we'll say if, and like I said, we've done this up. If the LED is on, then we are in learning mode. Now we could have done this with a variable and toggled the button, the LED ourselves, but we just use this mode. So like I said, we're taking advantage of some code that already exists in the driver. We could have coded it ourselves. And so then we'll say we'll set the color to something obvious, dramatically different. So we'll make it white. And then we'll go to the character display. We'll print that it is in learning mode. And that's all we need to do there. And then the else condition, if the button was pressed, taking us out of learning mode in this case where the LED is off, we're just going to say locked door. And that should be all the code that we need to write for this device. So, when you think about it, that's not a lot of code. And so let's compile this and see if I've made any typo errors. Oh, and apparently I've made an error here. Dot add E. Yeah, so I forgot. It's a hash table, so I have to add a key and a value. And so the value we don't really care about. All we really care about is that the key is in the hash table. So my boo-boo will throw in a 1, and that fixes that. So let's try compiling that. And we'll build the solution, and this should work out just fine. So the build succeeded. So we've designed our device and the hardware, and we'll go back to that for a second, and then we've written our code for it. So if you notice our designer here, and now if we look at what we've got for our actual device here, you can see that yeah, that's the relay, that's the button, that's our character display, the tunes module, the RFID reader, our LED, there's our power module, and such. And so it's really nice because the designer looks just like what we're building in real life, and we can see that I've got everything wired up, so from here to the socket too, and so it's really easy to actually go through and build devices with Gadgeteer because it tells you how to do the wiring. We'll go back into the code here for a sec. Now, the other thing is I like putting my projects on these. This is a Tamra Universal board. The bolts and everything, the holes for the modules and stuff are all the standard size so that you're able to use these boards. It makes it really easy to sort of keep everything neat and tidy. And when I do code camps or I'm working with students and stuff, we can give them the board where they've got everything. We can let them, connect the wires up if they want or whatever. But it just keeps things really tidy. Make sure I don't lose any modules or misplace anything, or I don't get stuff tangled up if I've got half-complete projects I'm putting away. So these Tamra boards are really handy. Now the other thing I should mention is when you buy like this module here, this is the RFID scanner. So this came from GHI Electronics. It's about 20 bucks. And I really should mention this because one of the things that you get with that module is you get 2 RFID cards. Now these aren't skimpy little cards. I mean, they're nice thick plastic and stuff like that. So these are just like the cards that you would have at work. And so it makes it really easy for you to to start testing and playing with these. And those cards, I've had those for a long time and they still look just as brand new. So how do we get our program from Visual Studio over onto our hardware device here? Well, this module over here, this is a power module, and it has a USB connection, and so you would plug this USB cable into here and then into your computer. Now I'm using an Alienware laptop, so I have USB 2 and USB 3 ports. For this project, I'm just going to connect it to a USB 3. It doesn't really matter which port you plug it into. So I'll plug this in, and away it goes. Now, how do we get our application over? Well, it's going to come in through USB, and Visual Studio is going to take care of putting everything over for us. So if we scroll up here to the top, we go over here, and let me scroll this up just so we can see what all it's doing. And if I hit the start button, so I mean you can go over here and there's like a build and a deploy and such, but we're just going to hit the start button. And so Visual Studio will go through and it'll compile everything up for us. It'll round up all the libraries and everything like that, bundle them all up into a package. And if we look here, program started, this is the debug output from this here, and so our application is actually running. So let's just kind of go up and see what all it does. It rounds up all the files and everything deploys it to us. So it makes it really, really easy to work with Gadgeteer, to build devices that go through, you know, design, code, run, fix, debug, run again. It makes it really, really easy. These cycles are really quick to do. And so, again, you know, why would you want to use a lesser tool when you can use Visual Studio with Gadgeteer? So let's go in, let's have a look at our device. So we'll take these two cards, and so if I scan them, hopefully you heard that the buzzer went and we got a message that said it was denied, and our LED went red. And we'll try that one again, and we'll try the other card, and we see that it's denied. So right now no card is going to work with here because the hash table is empty. So if we go into learning mode, so we press this button, put it into learning mode, and then like it says learning mode up here, we have a white LED. And so now if we scan a card over there, it now says that it's adding that card. So let's turn it off learning mode. So it's gone back, our LED's blue, it says that it's ready. And we'll take the one that we didn't add, we'll just give that a bit of scan. Yeah, it's denied. And then we'll take the card that we did add, we'll put it on there, and so it says it's entered. So we go to green, we see our little LED, our LED goes to green, our relay turned on, and then it turned off after the 3 seconds, and we heard that little beep. So let's try that again. Perfect. So let's go back into our learning mode, and we'll remove this card. And so it says that it's removing it. We'll turn it off learning mode. We'll try it again, and now it's denied. So our little device is working fairly well. We have a learning mode. We have a device that's smart enough to know which keys are allowed to open the door, which keys aren't. We have a relay that's powering up and powering down as required to operate the electric lock and such. And so that is our device. Now, I should point out one other thing. So let's say that you're having some trouble. Your device isn't quite working out the way you wanted it to. So one of the beautiful things is that you can set breakpoints in Visual Studio. So if I was to set a breakpoint here, and I do a scan, we'll see that we've hit our breakpoint. Now, it's not just enough to have breakpoints, but I can also look at what variables are. So that is the key, the RFID tag that's been read. We can see that we don't have any timers running. And then we can actually walk through our code and see what's going, what happens. This stuff is written to the character display. And we can see that we're not in learning mode because that LED is off. We can do a step in so we can see what's happening in the open door. So we can see that, oh yeah, that's being passed false. And we can come down here. Okay, this should say denied. We can see that is showing up on the character display. We'll hit the tunes. We can hear the buzzer go off. We can click this. The LED turns red. The relay is off, and we can see that it starts a timer. And so you have full debug capabilities. I mean, we can even go in and let's do that again. And let's say we want to change that. So we'll make that. We can even change variables. And step down, step through. And and our variables, they stay changed. So we have all sorts of things that we can do. We can come in here and we'll let this run. And let's say we want to scan this card. But we want this time, say we want to force it into here. So we can do stuff like set next statement and have it walk through our code like this. And this is handy for executing branches of code that may rarely ever occur, but it gives you a chance to debug them. The other nice thing about debugging when you're working with students is it gives you a chance to walk through their code and kind of work through with them what they expected to have happen versus what is actually happening. And so as an instructor for students, I can't imagine doing this any other way. Be able to walk through their code with them and find out what their train of thought was and how they wanted their application to work makes it so much easier to help them. With other device platforms, I have no idea how they do that. It must be an absolute nightmare to try and help students figure out their programs, because debugger is just a gotta have, and as professional developers they will have debuggers. I can't imagine professional tools without debugging. So anyway, I think that's about all I can really show you with this. Like I said, I will put all the source code and links for everything down below, and hopefully this has been a helpful demo for you to see the power of Gadgeteer and the platform and what it's capable of doing. I've used it to design hundreds of devices. I really enjoy working with this platform because it really kind of opens up allows me to capture the creativity of designing devices in real time, where I can just kind of throw modules on there and I can try different things quickly. I'm able to get things working quickly, and so it's been a really great tool for me as a device designer. And so until next time, happy gadgeteering.